Hello, welcome to Module 5, the Tower Operator course. This course will get you checked off on driving the tower, and it's the fifth and final module in our driver series. So you'll be completely clear and checked off to drive all Westchester fire apparatus after taking this module. Because you're already an engine, quint, and a ladder operator, this module will be much shorter than previous ones. It'll also be more specifically geared to the tower because we only have one of these apparatus. So our objectives for this course, we're going to review the Tower 71 staffing model. We're also going to talk about known issues with the staffing that we have with the tower and how we can overcome some of these issues. We're also going to talk about the electronic and hydraulic interface that controls the operators as well as the ladder. This is very much more unique than what we see in Quint 73 or Ladder 75. We're also going to talk about the location of our manual backup controls should we lose electronic power with the tower. We're also going to get into the specifics of the ladder itself and its capacity. We'll talk about some differences in tactics between platform operations versus the traditional aerials that you've been accustomed to, and talk about some of those unique features of Tower 71 that other trucks don't possess. So Tower 71 is an SPH 100 Suffin aerial. It has a 300-gallon poly water tank on it. That 300 gallons can go very, very quickly because it also has a 2,000-gallon per minute gale pump. It's also equipped with a 20-gallon Class A around-the-pump foam system with its own foam pro. This gives us the advantage of using, obviously, Class A foam. However, mainly for hand lines or if the tower is running in place of an engine or a point or ladder. So it does still give us the capability of extinguishing car fires, dumpster fires, but we would not want to use those foam operations for anything involving the master streams. As an SPH 100 light tower, it is 100-foot ladder. It has about 85 feet when it's completely extended at an 80-degree angle, so 85 feet vertical distance. The typical ladder is actually 1,000-pound tip load, so it's actually our most stout ladder. The only one that holds up to is Quint 73 when it's not flowing water. However, because of its extended distance, when the tower is flowing water, it's only a 500-pound tip load. The advantage to the tower, though, is that even when flowing water, that's 500 pounds at any angle. So we don't have to adjust or do a load chart. It does not matter what angle the ladder is set at or what height. As long as it's flowing water, it's 500 pounds in whatever position that you use. It also has a 15-degree negative deflection over the operators, so the ladder can go negative and sit on the ground. This is advantageous for us for any type of low-angle rescue, as long as it's not anything extremely steep, but we can go at least 15 degrees below ground level. The tower is also equipped with a 4,500 psi breathing cylinder, and so that's a much more unique feature than we see with the other apparatus, because it gives us the ability to take our own supplied air to the platform. The tower itself also has a 35-mile-per-hour wind load similar to Ladder 75. It has a 20-foot jack spread, but because they are H-jacks, they do have the ability to be short jacked. We'll talk about that operation. There are also two sets of stabilizers, one set in the rear and one set in the front. The rear stabilizers actually help to level the truck, while the front stabilizers actually lock in the front axle. There are also multiple safety features that prevent the ladder from maneuvering too close to the cab body. In fact, if you are trying to maneuver or boom the ladder around without the proper angle, not only will there be multiple alarms, but the ladder operations themselves will cease. So the operator controls are located behind the cab prior to the pump panel. There are multiple push buttons. The bottom buttons are down or engage operation, and the top buttons are up or disengage function. So these buttons are electronic. And the downside to that is that we're using the electronic features to power the hydraulics. So where you might be used to the ladder or to the quint, being able to feather your operation at a high speed or low speed, they don't have that ability with these. And you can engage high speed just by running the pump up to 1,400 RPMs. However, that's the only way to really achieve complete high speed with having the pump engaged. So these electronic valves control the hydraulics. When we push on the down side of the button, engages, the top button is disengage. Above the buttons is an electronic chart which tells us which outriggers are out and which outriggers are stow. So when the aerial PTO is engaged, when we have truck ready for ladder operations, all these lights will illuminate and allows us to have full tracking of what the apparatus. Once again, we have H-style jacks which work the tower, and we can short jack those to one side if we wish to. So we can use H-style jacks because we have a 20-foot jack spread. If we're operating in a narrow area, say an apartment complex with our cars on either side, we can short jack the one side and operate off the fully extended side. If we're trying to level the apparatus on the hillside, that's what the stabilizers are for. So our truck is actually equipped with rear stabilizers to level the apparatus. When you actually place the outriggers down, you would actually lift the front of the truck up slightly, taking the air out of the tires. You use the rear stabilizers to bring the truck back down just where the tires meet the ground. There's a second set of stabilizers in the front, which locks the front axle that completely stabilizes the entire platform. So realistically, we have 6 points of contact when we're using the tower's ladder. In the event that we lose our electronic interface completely due to a wiring issue or some type of issue with electronics, we do have emergency backup controls for the tower. These hydraulic power controls are located behind the cab, and in fact, we would have to tilt the cab to access them. They are true hydraulic controls, so it's very much an open and shut system. However, to access these, again, we have to tilt the cab completely. We have short jacked the tower. Remember, we can only operate off the fully extended side. So once we do that, we would have to use our emergency override. Because the safety features built into the tower does not allow you to operate if the outriggers are not going to work out unless you tell the truck that it's in fact exactly what you want to do. There are 2 buttons called interlock override, one located on the turntable and one located at the outrigger control panel. Both of these buttons have to be depressed in order for you to raise and boom up the aerial. Once the aerial is at the cradle, once the ladder is actually out, you can stop pressing the buttons and you have full access of the ladder at that point. However,
residential fire alarm contains 70s and 71s and 72. Residential fire alarm 8161 Watermark Court, Cross Street, Chestnut Boulevard, ESD 504, 1118, July Fire on 10.
fully extended side. If you try to steer to the outrigger, short jacked outrigger side, the ladder will stop. As a tower operator, understand that you're still using the Quint in a ladder concept. However, because of the decrease in water capacity, this vehicle cannot go without a water supply. If we're thinking of using the tower as a suppression feature for a car fire or a dumpster fire, call for an additional engine. The fact that it has 300 gallons of water and the size of a pump will cause the tower to run out of water very, very rapidly. Our best practices that we found is actually on structure advice to supply the tower with existing engines on sea. Versus the tower laying in, due to its limited staffing, probably over 2 people on it, it's best if an engine just gets supplied once they arrive on sea. Remember that at the end of the platform are 2 monitor nozzles. Each of these monitor nozzles can supply over 1,000 gallons per minute.
It's when you want to around 8161 Watermark Court, Fire Route 10, 1119. Night 70s around 1119.
So because it's a tower, it does have a platform. It's unique and helps us with some of our fire operations. So being in a platform truck versus a straight stick, if you will, is very, very advantageous for us, especially when it comes to defensive operations. We don't do too many defensive fires, However, in the event that we do have a prolonged incident or prolonged defensive fire, it is nice to have a platform in order to get above the fire and be able to provide manpower to keep watch and to maneuver those models around. Crews in the platform can remain stationary for prolonged periods of time because they have their own supplied air. Since the tower is equipped with its own breathing air cylinder, crews can simply just plug in to the supplied air connections in the bucket and remain stationary as long as they want. They can then use their SCBAs as an escape should the breathing air cylinder fail. Another nice thing about the platform is that if we're not flowing water, we have a 1,000-pound tip load. That 1,000-pound tip load can allow us to retrieve multiple victims at once for rescue. So, for instance, if we have multiple victims presenting on a balcony or a window, easily get that tower up to them, you retrieve multiple victims at a time, lower them to the ground like an elevator, and then re-extend the ladder, re-raise the ladder in order to go for the next victims. This is something that we cannot do with straight sticks, just because, again, a firefighter must ascend and descend every single time. Multiple victims can climb down the ladder, but we have to kind of conserve our space, conserve our weight per fly section. But the platform operation, we can meet that because we have a 1,000-pound tip. Not only does the platform make us very advantageous for conducting multiple rescues at once, we can also use it to shuttle tools to and from our initial incident scene. So let's say we're working a rooftop operation. We can use that tower to load it up with tools, saws, ropes, whatever we want, raise the tower up to wherever crews can meet us on the roof. They can retrieve all that equipment, put equipment back, lower it down, just use the tower as a giant elevator. It really makes for a much safer operation because now members don't have to ascend and descend aerial ladders carrying all that loose equipment, making us top heavy or falling. The tower bucket is also equipped with multiple points for 1.75 and 2.5-inch connections. We can use these connections pre-piped into the waterway as access to upper floors. So one suggestion would be, instead of stretching 2.5-inch hose up multiple flights of stairs to a high-rise pack, we could easily just connect our high-rise pack into the tower bucket, extend off the bucket to an upper floor wherever we wanted to go, and use the tower as actually our 2.5-inch supply line. We can vertically ventilate from the bucket as well. There is a override in the bucket which allows us to control the tilt and pitch. As we extend the ladder out, the bucket automatically always trying to auto level, but if we can disengage that auto leveling, we can actually nose our bucket down to allow us to vertically vent from the bucket. Again, providing us a stable platform and zero chance of collapse. At the end of the bucket is also a second ladder called a parapet ladder, which allows us to negotiate many of the parapets that we have in Westchester much easier than using a roof ladder or a little giant. Apparatus, nothing's quite perfect. Some of the issues that we do have with the platform is because of that larger footprint, it does restrict our access. Because the tower's jack spread is so much larger than any of the other apparatus, it really behooves us to negotiate and get into the sea so that we can completely set up as we need to. That larger footprint really kind of limits our mobility quite a bit. And also because we have the platform attached to the ladder, we cannot feed the ladder to tight places. One advantage to using straight stick is that we can feed it under wires a little bit easier or get into between trees or alleyways much easier than we can with having the large bucket. An additional feature that's on the bucket is the actual Stokes arms. So underneath the platform are two arms that can swing out. Those arms are designed to support the Stokes basket, and the tower is also equipped with a bridle and all the rope rescue equipment that the Quints and ladders have as well. Each arm is rated for 250 pounds by themselves, so we have a 500-pound rated capacity for those arms for the Stokes basket and for the civilian. Again, we would not be flowing water in these operations, so we have to detract 500 pounds for the victim, and then we only have 500 pounds of support that we can put in the bucket. Again, we can use that bucket with the Stokes arms to move people like an elevator, so we can just simply access upper areas, package our patients in the Stokes basket, secure them as necessary, and then move to the ground. So, without I'd have to say.
Main Falcon 10, 11, 25.
Rope system that we're looking to point on lateral engines. This picture shows those Stokes arms extended. You can see that they stick out quite a bit further than the platform, so the Stokes basket simply just rests on those, and then we clip it into place using rigging straps and also webbing to secure those to the arms. The Stokes baskets completely supported on each Stokes arm. Again, it's 500 pounds of brake capacity with an additional 500 that we can put in the platform. We use the webbing to just simply loop to the outside to secure from any lateral load. Slide off of the arms. And then it's actually rigged into the bucket as well using some rigging straps and hitches. One feature for the tower as well is that we can do what's called storefront or blitz attack, where we would pull up, boom the aerial out over the outriggers, place it on the ground, and we can use the monitor nozzles to attack us through. So we can use this as a blitz attack, similar tactics I've tried, but at the same time, we always have to be completely cognizant of the collapse zone. If we're placing the aerial directly on the ground at a 15-degree negative deflection off the ground, we have to understand that how close we have to get a good attack on monitor nozzles. We also have to be aware of the water supply challenges, so we must have a water supply established to engage in this tactic. And we also have to be mindful of our setup distance. So there's a certain amount of ladder distance that has to swing around in order to get the bucket on the ground to perform this tactic. So we'd have to set up a considerable distance away from the building. And sometimes with our strip centers, think of BOA or IKEA or any of these types of shops, the parking lots are very, very tight and they don't allow us much access to be able to perform this. It is a feature of tower operations. It is a tactic that's taught, but realistically, with our staffing, with our operations, this is something that we will probably rarely. So our hands-on skills for this module is we must rig the Stokes basket and understand how those work with lifting arms. You'll perform 10 aerial setups on the tower. You must complete the road course with the tower and operate the tower's waterway. Click the attached hyperlink